As we move away from traditional E&E architectures, with functions tightly coupled to ECUs, toward logically centralized and physically zonalized E&E architectures, the vehicle network has become the spine of this transformation. Of course, not everything can be transformed in one go. We will introduce new technologies and new approaches as they become available. So in this video, I will show you 3 recent innovations that will change in-vehicle networks forever. The first example is moving to a standard-based SerDes link. In order to connect cameras and displays to ADAS in cockpit high-performance compute ECUs, we are replacing the proprietary SerDes links with standardized SerDes and asymmetric Ethernet technology, based on the ASA-ML and ASA-MLE standard. NXP and multiple other semiconductor manufacturers have already implemented this standard, and with this, we will be able to establish a healthy multi-vendor ecosystem of suppliers, replacing the need for proprietary solutions. The second innovation is moving a bunch of scattered software into a centralized compute unit. We are taking the software that would be controlling interior light, seat adjustments, door electronics, and many more, and centralize them into one central compute, or the zonal controller ECUs. In order to achieve that, the automotive industry is pushing for the TC18 of Open Alliance and started to create an open market standard for the so-called remote control protocol. With this solution, sensors and actuators, instead of using their own microcontroller, can now be controlled remotely over standardized software interfaces and networking technology like TEM-based T1S. Ultimately, this remote control protocol, or RCP, solution will enable software-free sensors and actuators for the next generation of SDVs. The third innovation is using the existing Ethernet backbone to also communicate audio data. OEMs are constantly trying to further optimize the wire harness for cost and weight by pushing out overlay networks like the AudioNet domain. Proprietary audio bus solutions and its dedicated wires can be replaced, and instead the already existing Ethernet backbone is used. By utilizing the full TSN toolset, we can manage the data flow without exceeding latency limits. With this solution, OEMs can connect microphones to the closest zonal aggregator point, and audio amplifiers can be distributed and positioned closer to the speaker. The main benefit here is that they will be able to remove the entire audio wiring layer from their cars. At NXP, we are driving these 3 technologies and many more. It will ultimately change the in-vehicle networks of future software-defined vehicles forever.